my Algebra 2 friends. So we're back. This is a lesson 1.5. It's got two parts to it technically, but they all go together. So we're going to be solving linear inequalities. And if you remember anything about inequalities in Algebra 1, they look a whole lot like equations, but instead of equal signs, we're going to be dealing with greater than and less than signs. So I'm hoping you have a little bit of knowledge. Let me turn off my sound. You have a little bit of knowledge about interval notation from your algebra life before this. If not, we'll rediscover some things. So if I gave you a solution, and right away we're going to have an issue for my friends who have dyslexia, like me, the greater than less than signs themselves, some kids get them confused, and you can't think of them as alligators anymore, right? These aren't numbers, these are variables for half of the solution. So this one says x is less than 3. The way I remember what's a less than sign and what's a greater than sign is when I write a less than sign, to me it looks a lot like an L. So if I were to continue the word less, I would be like, oh yeah, that's an L, that's less than. So this does say all your numbers that are less than 3. So we're going to draw apparently a really horrible number line. And then I should number the number line, but 3 is the target number that I'm going to be graphing here. And I need to know where to be shading because it's not just the number 3. In fact, it's not the number 3. It's everything that's less than 3. So think of it like an arrow. If your X is on the left side, this is pointing, that away. Sorry, my camera's backwards. Pointing this way. And then this might be a little new for some of our friends. Back in the day when we were little kids, we could put an open circle here because it doesn't have an equal to bar on the inequality. So for Algebra 2, we're going to use parentheses instead of open circles. So anytime you have a less than or a greater than symbol without the equal to, meaning the endpoint doesn't count, you're going to use these soft parentheses. We'll notice in a next example that if we do have an equal to bar, we're going to use a bracket. All right, so this is where the interval notation comes in. I want you to tell me all the solutions from left to right. It has to be math, always is least to greatest. So if I kept graphing forever and ever to the left, and I think, okay, well, what number is it approaching? Because it's never going to stop, right? Number lines don't stop. Well, it's approaching what we call negative infinity. So if I pick up that interval and I say, well, it starts at negative infinity and it goes till 3, that's exactly what I write down. So here's a little weird rule in math because you can't actually get to infinity. You have to, those infinity, you have to put a soft parenthesis always on infinities. And then we already saw that there was a soft parenthesis on the 3. So what we had there was the solution, the graphed representation of the solution, and finally the interval notation. For Algebra 2, I'm going to ask you for all 3 things, but the interval notation is the important part. So this next example, we have this is now a greater than or equal to negative 2. So I'm going to go, let's keep my colors the same. I'm going to go draw apparently a really crooked number line. I'm going to put negative 2 somewhere in the middle. And then this time, because it says greater than, I'm going to be shading to the right of negative 2. And then or equal to means I do get to include negative 2 as part of my solution. I don't know why that bracket is not on the, oops, that's not what I wanted to do at all. Okay, whatever. I was trying to move it. Forget it. All right, so interval notation, always least to greatest. So our interval begins at negative 2, but this time we use a hard bracket because it does count as a solution. And then it's going to cover every single number up until now this time, because you're going to that side of the number line, you have an infinity up there. Infinities always get parentheses because you can't actually get there. It's a concept, not a number or a place. All right, so we're going to be solving inequalities now. You're going to notice it looks a whole lot like an equation, but a rule from Algebra 1, hopefully you remember this one. If not, here you go again. If you ever multiply or divide by a negative value, you have to reverse the inequality sign at that moment. So keep that in mind. And then another rule, it's not going to affect us on these first few, but just a good general rule, because you don't want to have to worry about where to shade and what it looks like, you want to keep it consistent, always keep your variable on the left. Okay, so just always keep the x on the left. So we're going to be solving this like an equation. We're going to move the 7 over, so we're going to add 7 to both sides. So far, we've got 3 halves x is greater than 9. And then remember, a real easy way to get rid of fraction coefficients would be to multiply by the reciprocal if it's just a single number. So I'm going to multiply by 2/3, which you are more than welcome to grab your calculator. So these cancel out to a 1x. I did not multiply by a negative value, so I don't need to flip the sign at all. It's still a greater than symbol. And then this would be 18/3 or a 6. So that, I guess I should just move this down. That is the solution, all numbers that are greater than 6. And then I'm going to graph it. So I'm going to pretend 6 is right there. And I want to graph all my numbers that are greater than 6. So that would be up here. There is no equal to symbol on the inequality, so I don't count 6 as a solution. I'm going to use one of those soft parentheses. And then I want to think about, okay, where is it heading? Off on the right, that's where positive infinity would be on the number line. So this interval solution goes from, I'm going to do it in another color here. Let's go green. All right, 6 to positive infinity. So there's your 3 representations of that solution. All right, so here, same idea, we got to solve. So I'm going to start by subtracting the 5. That is a positive 5. And I know some of you are looking ahead going, oh, we're going to have to do that thing. Yeah, we are. All right, so this equals 22 right now. We're going to divide both sides by -2, and this is what you were looking at. Anytime you divide or multiply by a negative coefficient, the inequality reverses. So this solution actually ends up to be this is now a less than or equal to -11 when you reduce that fraction. All right, number line. I'm going to pretend -11 is right here. And let's see, bracket. I want to go less than -11, so I'm shading everything less than it, which should look like that with a bracket. And then just to remind myself, you know, who lives down here, this is negative infinity on the left side of the number line. So my interval solution starts at negative infinity, reading it left to right, and then goes, oops, to -11. Said whoops a lot today. That's not good. All right, moving along. There's my big note. I suggest you always bring the variables to the left side, because if you don't have your variables on the left side, then you're going to have to pick up and flip your inequality around at some point. So I guess potato, tomato, as I like to say, it doesn't really matter. But just it's a good habit to keep your variable on the left for these problems, which y'all would have done on this next one anyways. I want to bring my variables to the left, so I'm going to subtract 7n. And while I'm doing some work here, I'm going to bring my non-variables to the right, so I'm going to subtract the 6 over here. And one thing I haven't done is put my line down the inequality symbol to kind of separate my equation. You are more than welcome to continue that habit. My work was getting really ugly, so I was not doing it, but you know what? It's not like it makes it any worse. All right, here we go. We have, let's see, a 2n. This is still a less than or equal to -2. Careful on that sign. Now this one always tricks kids because they're like, oh, it's negative. Yeah. But look what you're dividing by. Your coefficient that you're dividing by is a +2. You did not flip the sign on this one. So this solution is n is less than or equal to -1. So all of my numbers that are less than or equal to -1 is what I'm going to graph. So that would be bracket, right? And then less than -1. And now it's time for our interval. So remember, negative infinity is the infinity that lives on the left side of the number line. Your interval solution is all my numbers from that's ugly. Negative infinity to -1. Make sure you have a bracket on that -1. This interval notation, which is essentially a domain question, we'll talk about that later. This is a really good building block to something that's coming up next in our content, and it's something that'll kind of follow you through math. So make sure you're really getting an understanding of why we're writing it in that order. And yes, it's really picky. If you get it backwards, it is wrong. It has to be least to greatest or left to right. All right, so again, if you want to put that line down the equal sign, I didn't want to do that at all. You should, especially if you're having a rough day like I am, apparently. So there's a little distribution that we have to take care of over here on the right-hand side. This is now a 12 minus 4x. I think that was a greater than symbol. And then we still have a 5 minus 5x over here. So Always a good idea to keep your x's on the left for these. So I am going to move the 4x over by adding it. And while I'm moving things, let's go ahead and subtract the constant over to the right side. So what do we have here? We have a negative 1x. We still have a greater than or equal to, I think it was, and then a 7. So we're going to divide, careful, there's a negative 1 in front of here, and this is a moment where something weird happens. If you divide both sides by a negative 1, yes, this becomes positive x, but then we have to reverse the sign. So this is now a less than or equal to negative 7. Now, I kind of told you earlier in the video that I have some pretty intense dyslexia, which probably not what you want to hear from your math teacher, but think of it as a positive note. Like, if I can get through all that math in my life and continue to use math, even struggling with dyslexia, you know, there's hope for all of us, right? I am positive that already in this lesson I have misspoke a few times, so I apologize. If you're watching it with friends, just be like, "Ugh, Bruzo, you did it again." Yeah, apologies. It's gonna be a long year if you get irritated by my misspeaks on my videos, guys. I'm sorry. You just have to go with it. All right, I want all my numbers that are less than or equal to negative 7, so that would be this away, and then a bracket because of the equal to bar. So my interval notation, remember right down here on the left is the negative infinity. So your solution set goes from negative infinity to negative 7. The good news about reading them off a number line is they read like a book, you know, left to right. So that's kind of consistent with how you've always done your reading, which helps. I need to delete this page, otherwise I'm going to mess myself up later. All right, next, we're on the back side of the notes now for 1.5. This is kind of the second half to it. We're going to talk about what are called compound inequalities. So these are two inequalities in one, and they are joined by a conjunction, either the word and or the word or. And if you think about what those words mean in the English language, and is very restrictive. You have to satisfy both things that are being said. You know, you need to hold a full-time job and you have to get straight A's. Like, yikes, that's a lot to do. But if we switch that conjunction out for the word or, that's less restrictive, and it's just a union of the two things. So they can both happen. One can happen, the other one can happen, and it doesn't really matter because it's just, you can do this or you can do this. Can you do both? Sure, but you don't have to. So that's the English language difference between them. But let's look at the, well, real quick on my notes, I think a good thing to write down here, just so we have it in one space. When you have an and question, they're going to end up graphing where it's like a number, and then you're going to shade stuff in between. Could also be brackets. I don't want to indicate that it's only parentheses, okay? But the idea is it's this and it's everything in between it. That's the intersection look to math. So you're satisfying both of the inequalities. It's between the two values. That's what an and problem will always look like, as opposed to an or, which will look like this. And I'll give you some cutesy things to remember this. Again, you can use brackets. And we'll learn later you can actually use both. One could be a bracket, one could be a parenthesis. That's annoying. And then there are some special cases to these questions that are coming up. So we'll talk about that in a minute. So here's my cutesy way to remember ands and ors. If it's an and problem, it might just say the word and between two inequalities, or it'll be written in this notation here. This is an and problem, and I refer to it as a sandwich problem because your variable, which in this case is t, is sandwiched between two inequalities. So we're going to solve these two inequalities simultaneously. So you look on the inside of your algebra, you look right here, and you think to yourself, like, how would I get t by itself? And the answer is you'd add 8. So what's cool here is because you've got two inequalities, and now might be a good time to put some lines in if you haven't been doing that. I know I'm going to. Oh, apparently extra crooked. Okay, there we go. We're going to be adding 8 in all 3 places. So that's the big difference here. Because you're technically solving the right side inequality and the left side inequality. So what we have here, let's see, that's a 6 is less than or equal to 3t, which is less than or equal to 18. So again, I'm trying to solve for t, so my next step would be to divide by 3. And now we're ready to write down our solution. I'm going to write it down and then we'll discuss what it really means. So 6 divided by 3 is 2. So 2 is less than or equal to t, which is less than or equal to 6. So the way I want you to read this problem, and this is a little bit confusing, but this side y'all are fine, right? T is less than or equal to 6. Absolutely. And there's another half to this problem right here. I know it says 2 is less than or equal to t, but that's backwards. So that really says t is greater than or equal to 2. So I'm looking for you on the number line part here to graph me all the numbers that are both less than or equal to 6 and greater than or equal to 2. So what would that look like? Well, no surprise, guys. It would be all the numbers between between 2 and 6. So that would be these guys. And then because they both have equal to symbols, we're going to put brackets on both. Ands are my favorite because they're really stinking easy. Easier than ors. I'll show you that in a minute. All right, so there's an and. Here's another example of an and. Same idea. You're just going to solve this sandwich problem. Oh, man. There we go. Now be careful. I think this one has an equal to bar and that one doesn't, so watch out. All right, we're going to try to solve for x, so we're trying to solve this middle part here. I'm going to start by adding a 3 everywhere. And then we have negative 9 is, I believe I kind of wrote over it, less than or equal to 3x. And this one is just a less than symbol in 18. Alrighty, we're going to divide everybody by a 3 now. And we have our solution. So we have negative 3, which is less than or equal to x, which is less than 6. So this time, I still want all my values that are between negative 3 and 6. But as far as the endpoints go, we gotta be a little careful. Negative 3 has an equal to bar on it, so that means I can count negative 3 in my solution set. But I cannot count 6. It doesn't have that equal to symbol. So that's what your graph looks like, and the good news is your interval is just that picked up off the number line. So it starts at negative 3 with a bracket, and it goes to 6 with a parenthesis. That's the big difference on that one. Woo, weird. All right, so if they're sandwiched like that together, you have an and problem. That's the big takeaway here. Or, so here's how I remember what ors look like, and we're going to say this a lot in class. It looks like oars on a boat, like if you're on a paddle boat and you have these oars sticking out the side. So it's going one direction, it's going the other direction. And you'll know it's an or because it'll say or in the middle of your problem. So we have two different inequalities that you're trying to solve. But this time they really have nothing to do with each other than the final answer is going to be a graph that's graphed together. I really should try to make straighter lines here, guys. Oh, that's bad. Okay. I'm even using a tool that's supposed to make straight lines for me and I can't do it. All right, so I'm going to solve this one. I'm going to subtract 3. And then I'm going to divide by 2 on the next step. I can't even read my sign. I think it's a less than. Oh boy. If I had my life to live over again, I would have spaced that out more and made it bigger. Sorry. All right, so right now we have x is less than 1. I'm going to write down the word or in the middle here because that is part of my solution. All right, I'm going to do the same sort of solving on the other problem, but it has a totally different problem, so it's going to look a lot different. I'm going to add 7. Oh man, does that say greater? Guess we'll find out. All right, 4x is greater than 16. So dividing both sides by 4, we have x is greater than 4. So what I just wrote down here, that is your solution. It is very important that you guys put the word or in the middle. If you had nothing there, we're going to have trouble. If you put a weird symbol there that we're going to talk about in a minute, it's not going to be right either. I need the word or, O-R. So the graph, remember, it's going to kick out like oars on a boat. So make sure you put the numbers in the right number line order, 1 and 4, which one comes first on the number line. And yes, I do need to ask this every year. I don't really care that you put all the numbers in the middle of them. Just as long as they're in the right order is what I care about. So everything less than 1 would be this away with a parenthesis, or anything greater than 4, which would be this away with a parenthesis. All right, here's where it gets weird. Remember, on your number line, this is negative infinity and this is positive infinity. So when I go to write down my interval solution, I say, well, it starts at negative infinity, and then it colors until 1, and it closes with a soft parenthesis. But then it jumps over a whole bunch of stuff. Like there's a whole bunch of non-solutions in the middle there. So you're going to put what's called a union symbol. So write a big note to yourself. This guy is a union symbol. And it essentially means to add together two solutions. Two solution sets, I should say. It doesn't have a tail on it. So if I see you guys do this, I'm going to count it. Well, not wrong, but I'm going to put a really sad face and make sure you make a big deal about it till you start writing it correctly. I don't want you to go to college writing the wrong symbols, okay? All right, so then it picks up again at 4 with a parenthesis, then off to infinity. And that's your interval, my friends. All right, so there's another, oh, this one has stars on it, and you're going to learn pretty soon that anything with stars on it in our notes means it's an atypical case, a special case. So let's see what's going on here. All right, same idea. We're going to solve. Can you hear Vector in the background? We have one of those little robot dudes. I don't know why he woke up. Something about union of domain intervals really get Vector going, I guess. All right, here we're solving. We're going to subtract 7 from both sides. So we have negative 2x. I think that says less than or equal to negative 4. So then we're going to divide both sides by negative 2. Now, because we're dividing by a negative coefficient, that rule still applies. We do need to flip this sign. So I'm going to go ahead and write it down here this time. This now says x is greater than or equal to positive 2. Put down the word or, don't forget about him. And let's go ahead and solve this one. All right, so subtract 5 from both sides. Oh, man. All right, 2x is less than 10. And then dividing both sides by 2. X is less than 5. Why did I write it there? It goes down here. I guess I'll go ahead and write this one here. Confuse my kids later, huh? Okay, let's graph. Remember, it's supposed to be kicking oars on a boat, huh? So, what happens is sometimes kids get used to what they're supposed to look like, right? And then they just are like, 2, 5, kick out, done. And maybe that is the right answer. But let's look closer at this one. There were stars on it after all. It says x is greater than or equal to 2. So that would be like this. So already I'm a little confused. And then this guy says x is less than 5. So that would be like this. And then, yeah. So what's going on, man? All right, so here's what's happening. You had oars on a boat, but because of where their solution sets were, they overlapped. Like the oars were overlapping and kicking out, but like already starting in an overlapped fashion. So the oars crossed, essentially. So when I asked myself, what did I just color? Well, the answer is you colored everything, man. You got negative infinity, and then you hit everything, all wrong way, everything up to infinity. And that's your solution. This is the equivalent of saying all real numbers when you were in Algebra 1. So all real solutions work. All right, so that's your lesson on 1.5. Had a lot in there, right? But a good chunk of that was review, so I hope it seemed a little familiar. You know me. I love when you guys do your work in colors. You need to make sure you go practice this right away and have your notes handy so you can really see the difference between the singular inequalities and then the two compound inequalities, the ands versus the ors. All of this is going into one section for your grade book. They are all interconnected, of course, but practice, guys. That's the glue that's going to stick it in your head, okay? All right, good luck, everybody.